Hello, today we're going to talk about statically equivalent systems. So, what is a statically equivalent system? Well, two sets of forces are considered statically equivalent if they cause the same set of reaction forces and moments when they're applied to some body. So, in this way, the two sets of forces are kind of interchangeable, at least for the statics problems that we're going to be solving. So, in statics analysis, we're going to often use this. If we've got some big complicated loading setup, we might simplify that into a single statically equivalent force to kind of simplify later analysis. So an example of a statically equivalent system, imagine we've got one 200-pound man sitting on a beam and two 100-pound children also standing on this beam. So if it's kind of evenly spaced like this, our 200-pound man is going to cause 100-pound reaction forces at each end of the beam that's being supported. And these two 100-pound children are each going to also cause the same set of 100-pound reaction forces. So because the reactions are exactly the same here, our systems are statically equivalent. This 200-pound force in the center is going to be statically equivalent to these two 100-pound forces kind of evenly spaced on our beam. So to determine if sets of forces are statically equivalent to one another, there's really no shortcut. So we're going to determine the reaction forces in each case and determine if they're the same. So set up a free body diagram for each situation, write out the equations of equilibrium, and we're going to solve for the reaction forces. And in the end, we just compare them. If those reaction forces are the same, it's going to be two statically equivalent sets of forces that caused them. If they're not the same, then those sets of forces are not statically equivalent. So that is a way to determine if the sets of forces are statically equivalent. But what if we want to find a single force that's going to be statically equivalent to some complicated loading scheme? So I want to find that one force that would fit into a statically equivalent system. So to do this, I've got my original scenario. I've got three forces acting on this beam. It's anchored into the wall. So this is a fixed connection. It's going to have a force in the x, force in the y, and a moment, at least possibly. So first I draw a free body diagram of the original situation, solve for the reaction forces. So this is an extended body. I just do an extended body analysis. So remove the background. And I've got three possible forces. Like I said, force in the x, force in the y, and a moment at that connection to the wall. And I should be able to solve for the magnitudes of each of those. So now I'm going to draw a new free body diagram with the same reaction forces, and it's going to have one unknown force. This is going to be my single force that is statically equivalent to my original scenario. So I get rid of those original forces, and I add in one force. I don't know the magnitude, I don't know the direction, I don't know the point of application. This is just kind of a shot in the dark. So at this point, I am going to write out the equations for this new free body diagram that I have here. So this means I'm going to need some variables to describe the position, direction, and magnitude of this vector. And I'm going to write those into the equations. And so my position is going to be some distance along the beam. I've got some angle theta to determine the direction. Some force F is the magnitude of that vector. And so I've got those three unknowns. Remember, I know the reaction forces. I know what they have to be for this to be equivalent. So three unknowns: magnitude, direction, point of application. Three equations. So I've got the potential to solve for all these things. And once I write all these out, I'm going to use the force equations, so force in the x, force in the y, to usually solve for the magnitude and the direction first. Once I solve for that, I can go back and use the moment equations to solve for this distance d, or the point of application of my force. I can also do this in 3D problems. It's going to be considerably more complicated because there's going to be a magnitude, two angles for the direction, and then for point of application I have three possible. I'm going to have an x, y, and a z coordinate of the point of application. So I need all six of those equations to solve for that. But with that, That's all I have for statically equivalent systems. Thank you for watching, and I hope to see you again.